When it comes time for your database to retrieve the information that you've painstakingly stored, it will often be helpful if the most commonly searched fields contain something called indexes. Indexes are a way for the database to keep track of what records have already been added to your table and to quickly retrieve a record or a group of records when they're requested. To get a feel for how indexes work, let's think about how a phone book is structured. Phone books typically provide a listing of people and their telephone number and are indexed by the last name of the individual person. If I were to give you a name to find, say Karen Reese, it would be very easy to jump to the correct page in the R section and find her telephone number. You can do this because the last names are ordered alphabetically, which makes it easy for you to quickly find the right name and its corresponding phone number. However, if I were to give you just a telephone number, your task would be infinitely more difficult to find out who it belonged to. In order to find the right person, you would need to start at the beginning and check the number I gave you against every other number throughout the whole book until you happened across the right one. Only then could you tell me who it belonged to. You can see that having a telephone directory that is indexed by phone number instead of last name would make your job much easier. This is exactly how your database would function in the same situation. In the database management system, providing these types of alternate indexing schemes allow the database to find requested information much faster. By default, the primary key field is always indexed. Every time you add a new record to the table, the database is able to quickly search the index for the primary key value to see if it's already been used. However, we can add indexes to any additional fields, besides the primary key, that we feel would improve the efficiency of the database. For instance, in our customer table, we already have an index on the primary key customer ID. This makes it easy to pull up listings of invoices associated with that customer, since all of the invoices will reference the customer ID value. But what happens if the customer calls requesting a status update on a recently placed order? Since it's unlikely that they'll know their ID number, the service representative will need an alternate way of quickly finding their order. We could find all of the orders placed by people with the same last name. Or maybe our business procedure indicates that the customer provides us with their telephone number, or maybe the last 4 digits of the credit card they used. Each of these values could be used to search the database to find their order information, and all are candidates for possible fields to add indexes on. The obvious question now becomes, why don't we add indexes to all of our columns? The reason we want to be selective in which columns we decide to add indexes on is because indexes will slow down the database's ability to add new records. If you think about adding indexes as printing additional telephone directories sorted by different values, then you can quickly see that adding a new person to the phone book really means that you need to update all of the index directories as well. This is the same in the database. Every time you add a new record to a table or update or delete an existing record, all of the indexes need to be rebuilt. If you have too many indexes, this can dramatically impact the speed at which the database can add new records to a table. It's important to note that not having an index on a column doesn't prevent you from searching the database by that field. Just like searching through the phone book armed with only a telephone number, the process is still doable, it's just not very efficient. Depending on the size of your data tables and the types of questions you typically ask of the data, adding indexes might not offer any noticeable speed increases. So that's how indexes work in a relational database. They help the system find specific pieces of information quickly, but they do so at the speed at which a new record can get added to the database. As a final update to our table design worksheets, go through and identify all of the fields within your tables that you are likely to search on regularly. This includes creating indexes on your foreign key fields that connect to other tables in your database, as well as additional fields that your interviews indicated would be helpful to use as search terms for finding specific records quickly.